Hi friends, let's solve this problem. Let A be the set of all points alpha comma beta such that the area of triangle formed by the points 5, 6, 3, 2 and alpha comma beta is 12 square units. Then the least possible length of a line segment joining the origin to a point in A is okay. So there are 3 points given, which is 5, 6, 5, 6, 3, 2 and alpha comma beta. So these are the points which lies in the plane. So by using determinant, we can calculate the area of a triangle formed by these three vertex. So by using determinant, the area of a triangle is given by 1 by 2. Determinant is going to be 5, 6, 1. See, last column is fixed as 1. Then the coordinate, first coordinate 5, 6. Second, it's a 3, 2. Third, it's an alpha beta. So by using this determinant concept, we can calculate the area of the triangle. So it is given that the area of a triangle is 12. Okay, so the value of this will be plus minus 12. Okay, because whatever the value of the determinant we get, we take the modulus of that, and that's the value of the area. So if we remove the modulus, so it's going to be plus minus 12. Because if we change the order of this point, the value of the determinant, basically we are interchanging rows, so the value of the determinant will change by negative. That's why the value of this, we take it as a plus minus 12. So now let's simplify the determinant. Let's calculate the determinant on the left hand side. So we get 5 times 2 minus beta minus 6 times 3 minus alpha plus 1 time 3 beta minus 2 alpha. This equals to plus minus 24. Okay. So now if we simplify this, we get 4 alpha minus 2 beta minus 8 is equals to plus minus 24. So now we can see that we can have a alpha depending on beta. Okay. So now what we have to do, we have to find the least possible length of the line segment joining the origin to a point in A. Okay. So A point is nothing but alpha comma beta. So it's a distance from origin is a square root of alpha square plus beta square. It's distance from origin. So we have to minimize this. Okay, as we want to find least possible length, we want to find minimum value of this square root. But for simplification, we can find the minimum value of alpha square plus beta square, and then we take the square root of that. We can have such kind of approach. Okay, because as this is a function of two variables, we are going to convert into a function of one variable by using the relation which we are getting from the determinant, or we are getting from the area of the triangle. So once it gets function of a one variable, then we can find the maximum and minimum of this function by using the idea of function of one variable by using derivatives. Okay, so anyway, so here we have two possibilities. Let's see. So here we have two possibilities. First possibility is 4 alpha minus 2 beta minus 8 is equals to 24, and we have 4 alpha minus 2 beta minus 8 is equals to minus 24. Okay, so from here we get 4 alpha minus 2 beta is equals to 32, and from here we get 4 alpha minus 2 beta is equals to minus 16. So then we get 2 alpha minus beta is equals to 16, and here we get 2 alpha minus beta is equals to minus 8. Done. So now let's take the case 1. Let's take this as a case 1, and let's take this as a case 2. So we start with the case 1. So here if we start with the case 1, so we have to find minimum value of alpha square plus beta square. But what is beta from here? From the case 1, what is the value of beta? It's a 2 alpha minus 16. That's the value of beta. So here we get alpha square plus 2 alpha minus 16. It's a square. So now we want to find minimum value of this. So that is nothing but talking about maximum and minimum of a function. So now this is a function of one variable f of alpha. So whatever the minimum value we are going to get of this function, we will take the square root, and that's nothing but the least distance of the point in A from the origin. So now how we calculate maximum minimum of this function? We find the first derivative f dash of alpha. So this is equals to 2 alpha plus 2 times 2 alpha minus 16 into 2 by using chain rule. And then we are going to equate it to 0, and we are going to see what are the roots of this. Okay, so what we are going to get? We are going to get alpha plus 4 alpha minus 32 is equals to 0. So we are going to get alpha as a 32 by 5. We are going to get alpha as a 32 by 5. So now, as we are getting only one point, and that is going to be the minima, there is nothing else possible. Even if you want, you can check f double dash of alpha. So f double dash of alpha is going to be 2 times plus 2 times 2 into, here it's going to be a 2. The derivative of alpha is going to be 1 anyway. So we end up with, is going to be 8 plus 2, it's going to be 10, which is greater than 0. So which says that this point is a minima. So once we know, as we know the value of alpha, we can get the minimum value of f of alpha. So what is going to be the minimum value of f of alpha? So it's going to be f of 32 by 5, which is equals to square root of 32 by 5 square plus, then it's a 2 alpha minus 16. So then 2 alpha, so it's a 2 times 32 by 5 minus 16 square. Okay. Anyway, I think I should not take the square root. We are finding the minimum value of f of alpha first, and then at the end we will take the square root. Okay. So now, so, so now this is equals to. So this turns out to be, actually we can just simplify. It's a 32 by 5 the whole square plus, and here we get, it's a 16 5s are 80. Yeah, we get minus 16 by 5 the whole square. Okay, so what we can do, we can take 16 square common. We can take 16 square common because anyway we are going to take a square root, and then this is 2 2s are, what we are left with, 2 2s are 4. So it's a 4 plus 1, it's going to be 5, and this upon 5 square. Okay, and then this is the minimum value of alpha square plus beta square. But what we want to find, we want to find the square root of this. Okay, a minimum value of square root of this. So what we get, we get square root of, square root of f of alpha, we get square root of f of alpha is equals to, it's a square root of 16 square by 5 square into 5. Okay, so 16 square by 5 square into 5. So this turns out to be 16 by 5 square root of 5, which is equals to 16 by square root of 5. This is the one answer from the first case. Okay, now we have to consider the another case. Now we have to consider another case and check what is the minimum value that we are getting from that. So now let's start with the another case. So now what is the equation that we have? We have 2 alpha minus beta is equals to minus 8. Okay, so the value of beta we get is 2 alpha plus 8. So then what is a f of alpha? F of alpha is equals to alpha square plus beta square. So it's a 2 alpha plus 8 square. Okay, now let's find the maximum minimum of this function. So f dash of alpha is equals to it's a 2 alpha plus 2 times 2 alpha plus 8 into 2. Okay, then we are going to equate this to 0, so we can take 2 common and what we are left with alpha plus 2 alpha plus 8 into 2 is equals to 0. So we are left with alpha plus 4 alpha plus 16 equals to 0. The similar work what we did for the first case. Okay, so now we get alpha 5 alpha is equals to minus 16. So we get alpha is equals to minus 16 by 5. So now what is our f of alpha? Our f of alpha is alpha square plus beta square. No, actually this is going to be a maxima and minima. Definitely is again a minima point. As I said that we are just getting one value and the question says that it has a least value because there are options given. So definitely this is the minima. So even if you want, you can check that what is f of f double dash of alpha, and it's going to be a constant value, positive value. So it's a again it turns out to be it's a 10. Again it's 10 which is greater than 0, which says that alpha is equal to minus 16 by 5 is the minima. So now let's find the function value at this minima. So it's going to be minus 16 by 5 square plus then 2 beta, no sorry, beta square, so it's a 2 alpha, so it's a 2 times minus 16 by 5 plus 8. Okay, then the square of this. Done. So now what we have to do, we have to just simplify this. So now let's simplify this. So what we get this as a 256 by 25 plus, then here we get it as a, it's going to be 8 by 5, so it's going to be 64 by 25. So now this is equals to 320 by 25. So now this is the value of alpha square plus beta square, and we want to find minimum value of square root of alpha square plus beta square. So we take the square root of f of alpha. So square root of f of alpha is nothing but square root of 320 by 25, which is equals to 8 square root of 5. By factorization you can quickly get this answer. So this is equals to 8 by square root of 5, and this is the answer from the second case. So now let's compare. So from the first case we were getting answer as, a 16 by root square root of 5, and the second it's a 8 by square root of 5. So 8 by square root of 5 is the minimum value. So the answer is 8 by square root of 5. So let's see what is the option. What is the correct option here? So we can see that option D is correct, 8 by square root of 5. Thank you.